Hey everyone, and welcome to Types of Quadrilaterals. This is Geometry Lesson 7. The goals of today's lesson is basically to make sure you know the definitions of special plane figures and all their properties. You need to make sure that you understand the meaning of quadrilaterals and triangles. And you can have a look in your textbook for that as well, but I put most of it in here. And also, just making sure that you understand all the tests for special quadrilaterals, and this is covering exercise 4.7 from your textbook. Nice. Okay, so the first thing we want to do is make sure you know what a quadrilateral is. So what's quadrilateral? Well, a quadrilateral is any four-sided, and we're going to add to that any four-sided figure, any four-sided plane, as in two-dimensional closed figure. So you can't have that's four-sided but it's not closed, so it's not a quadrilateral. Okay. Alright. You also need to make sure that you know why the angle sum of a quadrilateral is 360 degrees. So if you have a look up here at this picture, then what they've done is they're saying, well, they want you to draw this diagonal AC in. And they're going to tell you that angle ADC, this one here, plus angle DCA, this one here, plus angle CAD, this one here, is equal to 180 because it's an angle sum of a triangle. Same with all the angles in the other triangle. And so when you add all those together, you get 360. And that's why the angle sum in a quadrilateral is 360 degrees, because it's basically two triangles. That's what they're saying. Okay. Cool. So the next couple of pages is just all the different parallelograms and the tests for those parallelograms. So it's really important that you know all of those things. Okay. That you know those properties, that you memorize them and you learn them, write them out, stick them on your wall, your toilet door, whatever. Okay. Cool. So we're going to be using some of those properties in these examples, and we'll also be using some of the stuff that we learned in previous lessons in congruence and stuff like that. So if you look at this first question, it says PQRS is a rectangle. So that's really, really helpful because that tells me I can use all the properties of a rectangle. They're telling me M is the midpoint of SR, so that means that this is equal to this. And PM and QM are joined. Okay. Their instruction is to prove that PM is equal to QM. So they want me to show that PM here, this line, is equal to QM, this line here. So I'm going to need to do a congruence proof. Okay. So I'm going to go in triangle PSM and triangle QRM. Well, I can straight out say that SM is equal to MR, and that's because it's equal lengths are due to midpoint M. Some sort of clear reasoning like that. I can also say that PS is equal to QR, and the reason I can say that is that they're actually opposite sides of a rectangle are equal. So that's a property of a rectangle I need to know. And then I can also say that this angle in here, angle S is equal to angle R equals to 90 degrees. And that's also a property of a rectangle. So I've basically just done a congruence proof to show triangle PSM is congruent to triangle QRM, and the test I used was SAS, because you can see the included angle here in both of those. So there I'm going to say, therefore, PM equals to QM, and my famous reason is matching sides of congruent triangles are equal. And we're done on that question. Awesome. Cool. So question 2 is another problem that I'm asked to do, and it says PQRS is a square. And it says, so if it's a square, that tells me that 4 sides are equal. It says M is the midpoint of PQ, and N is the midpoint of PS. So that also tells me that this is equal to this. And it tells me that this here is equal to this here. It says SM and N are adjoined. Prove that SM equals NR. So that's my job. So another congruence proof I need to do. So I'm going to go in triangle SPM and triangle RSN. I'm going to say PM equals to SN, and they're basically, like before, halves of equal sides because of those midpoints. Then I'm going to say angle P equals angle S, which is 90 degrees, and that is the property of a square. I'm also then going to say that so what have we got so far? We've got angle P, so this angle here equals angle S, so we've got the angle. We've got PM equals SN, because they were of the same square sign. And I can say PS equals SR, because equal sides of a square. And then I've proved my 2 triangles are congruent, so I'm going to go triangle SPM is congruent to triangle RSN, and my proof then is SAS. You can see the included angles here. Awesome, and I'm going to go, therefore, SM equals NR, and my classic reason again, matching sides of congruent triangles are equal. Done. So you should be seeing a pattern in these questions. We're proving they're congruent first, and then we're using that to answer the question. Okay, and that's pretty much what we're going to be doing for most of these styles of questions. So let's look at number 3, and if we have time we'll do number 4, otherwise that will be for you guys. So we go. Okay, first one, ABCD is a parallelogram. So if it's a parallelogram, that tells me these 2 sides are parallel, and these 2 sides are parallel. It says the points M and N lie on the sides A, B, and DC so that AM equals CN, and that's marked. DM and BM are joined. Prove that DM equals BN, and that DMBN is a parallelogram. This one's a little tricky. So again, I'm going to need to prove some congruent triangles. The end ones, actually. So I'm going to go in triangle AMD and triangle CNB. Now, why would I be doing that? Why am I trying to prove these end triangles congruent? Well, if I can prove MD is equal to BN, I've won half the battle on the parallelogram. So that's why I'm doing that. So AM equals to CN, and that's given. Angle A equals angle C, because opposite angles in a parallelogram are equal, and that's a property you need to know. And then I can say AD equals BC, and another property of a parallelogram is opposite sides, only one S, opposite sides in a parallelogram are equal. Okay. And therefore, the two triangles are in fact congruent by SAS. Cool. So now that I've done that, I can say that DM is equal to BN. And again, I'm going to use my classic line. But I need to show that it's a parallelogram as well. Okay. So basically, since BM equals DM, because they are equal lengths subtracted from equal sides, basically DMBN is a parallelogram. Okay, so I've proven they're congruent, which means these are actually equal. But not only that, since BM equals DN, okay, so these are equal here too, because they were equal side lengths taken away from this equal side, then it has to be a parallelogram. So have a look over that one. If you have any questions or something doesn't make sense, please write it down, and then we can talk about it together. Alright, the last one doesn't seem like we're going to have time for. But this is out of your textbook, this example, so you can use it to help you do it. But there's two equal circles, and they have centers O and P. The question asks you to prove that OAPB is a rhombus. So to do that, you'll need to start off by proving it's a rhombus first. Okay, and you can do that by basically going that OA equals to OB, because they are equal radii of a circle. And it's the same for, so similarly for PA and PB.